Hello guys and welcome back. So I have the preview here and it took a couple of minutes for this to finish, and you can see we have some really cool emission at the beginning. We have very interesting details here. Now after frame 50 the reason it turns black is because we have that attraction force that's gonna kick in and it's gonna start attracting the particles to the center, and this is the transition frame where it's gonna take over, so it's getting darker and slower. And so we need to turn that off or tweak it or see how it's going to work with this effect. But overall I'm pretty happy with this. You can see here there's a lot of cool parts coming up and getting attracted again. There's a lot of movements here, and the second part as well looks very cool. So I'm pretty happy with this. The color as well, there's tons of details and it feels like they're getting advected and smoothed out nicely. So pretty happy with this. I just need to increase the resolution, and I think that's pretty much it for the particles related stuff. I have somewhat of a bonus content. I'm not sure yet. I'm still tweaking this. I don't have the final result, but I want to show the concept and the idea behind it. And let me show what I currently have. It's not perfect by any mean, but the idea I think is gonna work nicely. So let's set this to 30. And what I want to show you guys is how we can create some nice rolling smoke that we see a lot. For example, when you get a helicopter getting closer to the ground, it starts kicking up dust and smoke and it starts rolling in that motion. And this technique here can be used in so many different ways. And again, this is just a prototype. You can see it's going crazy over here, but the beginning I think is working, and we just have to tweak a few things to get the proper motion. So how did I do this? Well, the first thing, I isolated the particles that we created from week 2, the collision part with of the dust with the ground. So this is what I have, and then yeah, I think that's it. This is just the sim of the particles traveling along the ground, and then it's getting isolated with the velocity, and there is a point replicate to add more details to it. So I'm using that to create a volume like this, just converting those points into particles, converting those points into a volume. Okay, and then the important bits is the force that we're going to create, and I'm creating this vortex like shape that I'm using as a force right now. And you can see the display of the volume trail, how it is swirling as it gets towards the center. Now how did I do this? Well, let me show you. First of all, I created a circle. Let's find these guys. So I created a circle that animates along that, respecting the silhouette of this. Let me template the circle. So this is my circle. It's just expanding with as the particle progresses, this circle expands. And then I'm using a poly wire to convert this into a tube, basically. Let's add some division. Okay, so we have a tube, and I'm going to convert this tube into a fog volume and fill the interior. Cool. So we talked about SDFs last week, the beginning of this week. And if we create an SDF of this, we know, because it's displaying the normals, we know that it knows how far we are inside the surface. We can also compute, and it does that using the gradient information. We can take any smoke sim and compute the gradient information for it. So we have this density field, and we need this density because we're going to be interacting with smoke. So we need a density field, and I'm going to use a VDB analysis to create this gradient information needed for this. Okay, so here I'm going to say density. The operation is I want to compute the gradient. So it takes a scalar field, which is the density, and produces a vector. And I'm going to call this gradient field, I'm going to put it into the velocity field for now. Okay, and let's merge these two, and let me copy the scatter and this. So what I'm going to do is I'm going to create a bunch of nodes, a bunch of points on this VDB from particle, and then use a volume trail and use this velocity here to preview that. Now look at this. We have points. We have trails pointing to the isosurface, to the silhouette of this, and as we get deeper, it gets stronger. The trail gets stronger. That's because it needs to reach further to get to the isosurface. So this is the preview of what the gradient looks like. But we can take this gradient and process this information to generate something a bit more interesting. Let's create a volume vol and dive inside, and let's import the velocity val, and this is a vector field, and I'm going to bind export that, so we can add noise, we can add anything we want to this velocity field, but for now I'm just gonna do something else. I'm going to compute the cross product of this velocity field vector, or the gradient, and an up vector, and plug that out as the velocity. So once we do that, we get a swirly motion going this way. Okay, if we take this result and compute the cross product between this vector and this vector, which is going this way, we're going to get another vector that is much more interesting. So let me copy this node, and I want to compute the cross product of this result with the original velocity. And let's take a look at this. And boom, we have the swirly motion that we need. Now all we have to do, this is animated so it expands as the circle expands. We can also animate the height and change it in any way we want, and add velocity and everything. So we can add some velocity now, some noise, sorry. Let's add this. Too much, so let's lower this to 0.1. 0.2, something like that, 0.1. And now all we have to do is find a way to inject this into the sim and use this field as a force to drive the sim. Now one thing that Houdini has inside the solver, when we create a source volume, we can see there's multiple options here. One of them is pump. And pump is the most efficient way to use external volumes and inject the velocity into the data, into the sim. And all we have to do is we have to just import this data into the source volume and tell Houdini how to use it. So let me create a null node, and let's call this out pump force. Copy this name. Okay, I'm gonna paste it here, and this pump force expects the fields to be named specific names, and in this case, if we go under subto binds, it expects the field to be named pump and pump val. The pump is a scalar field, and it is in this case our density field that will be used as a mask for Houdini to know the area that it needs to inject the velocity in, because we want the sim to only change where there is data. So this is going to be used as a mask. And in this case, the field is named density in our input. The velocity field that we have is named vel. It's not pump vel. So I'm going to connect this guy. I'm going to increase the velocity to 50. And I have the source of the object, which is, let me show you, which is this guy. So this is our density source. Okay. And I also have a bound node to help the sim know where the data is. Let's go back in, go to the first frame. And this is the same setup that I used for the dust hit, I believe. I just copied it and updated the nodes, that's all. And I have a ground for the collision. And let's lower this to 1.5. And we'll probably have to animate the velocity so that it starts strong in the beginning and then dies off, or dies off as the object progresses. So this is with the force set to 50. And I think I need to move the ground down a bit. And you can see that it's working. So let's go back up. Let's take a look. And let's use a visualization node. So I'm just going to steal this. Okay. I don't need 1024. Set this to 2, 3. And you can see we're getting some very cool motion coming in, being injected into the sim. Let me do a play blast of 25 frames of this. Now, we'll do it together. Let's change this to black. And again, I've not done any tweaking or did this before. I'm just building it now live and seeing it for the first time with you guys. So there's definitely a lot of tweak to do here. But what I wanted to show is how we can use the gradient information, which is basically how far each voxel is from the isosurface, and then using cross product to compute a swirly vector or double cross product to get that swirly vector created. Cool. So definitely there's a lot of added motion here. So let's turn this one off. And what I'm gonna do is there is a tool to snapshot. So view memory. We can capture the viewport. I'm gonna click here, I believe. Okay, let's see. And Houdini crashed. Okay, let me pause. Cool, so we're back and I have the 24 frames here. So we're gonna have this in play because Houdini crashed. It's gonna hopefully keep this session. If not, then we know that there's a lot of swirly motion happening. And now I'm gonna dive inside and disable this pump force to see the difference. Okay, let's hit play. For some reason it's taking some time to create the first frame. Could be from the VDB from particles node. Let's go. Cool, so you can see now it's very, very flat, and the stronger the force we have, the more volume we're gonna get. So let's do one more test and increase this quite a bit, 500. And again, this is, to be clear, this is just an experimental to show the gradient idea and how to inject velocity using the pump force in the smoke sim. Also, you can see here, it's much stronger for sure. Cool. Let's go up. Alright, I think that's pretty much it for this week. Thank you guys for watching, and see you in a bit.